In this video, we are going to explore matrices and matrix operations. We're going to find the sum and difference of two matrices. We're going to find the scalar multiple of a matrix. And then we're going to multiply or find the product of two matrices. So the question to ponder, when is it better to solve for x instead of y when using substitution? Well, the answer is when there is no coefficient on x and there is on y, which would produce fractions. So in that case, I'd solve for x instead of y. Or say x is linear and you have maybe x plus y squared is equal to 3. In that case, I would absolutely solve for x rather than y, because it'd be easier, because if you solve for y, you'd end up with a plus and minus, and so you'd have to do it twice. You'd have to solve out whatever it is you're doing twice, one for the negative and one for the positive. What we're going to be doing today is we're going to solve linear equations. And with linear equations, we can put those into a matrix. And basically, what a matrix is just row and columns of the coefficients or numbers, and we peel off the variables. And we can have more than one variable. We can have x, y, and z, even w if it's needed. And the way that we talk about a matrix is the size of the matrix. So we say there are m rows and n columns. And that's how we tell you about the matrix. We tell you it's the size of m by n. And typically when we talk about a matrix, we use capital letters to label the matrix. And then inside the matrix, we use these big brackets to define where the matrix is. And each one of these entries are lowercase, whatever variable we used here. So if we used an uppercase A, we use lowercase a here, uppercase B, lowercase b, etc. Now these little numbers, these subscripts on each one of these entries tells us first the row and then the column. So when I say A11, I mean I'm in row 1, column 1. If I say A23, I'm in row 2, column 3. So we do the row position first. So when we say A, we do the row position. So we do row, and then we do the column position number. So A46 is row 4 and then column 6. So that's how we keep track of what is in each position of a matrix, is by telling you which row it is and which column it's in. Now, we are allowed to add and subtract matrices. Pretty straightforward. But for us to add and subtract matrices, they have to be the same size, which means they have to have the same number of rows as they do columns. And when we do addition or subtraction of matrices, we're just adding and subtracting each entry. So say my matrix A is 1, 2, 3, and 4, and say my matrix B is 2, 5, 7, and 9. I can take A and subtract off B. So in the first position, it'd be 1 minus 2. So I'm going to take this 1 and subtract off this 2. And then I'd have 2 minus 5, this 2 minus this 5. And then I'd have 3 minus 7, this 3 minus this 7. And then I'd have 4 minus 9, this 4 subtracting this 9. And so my answer would be, when I got done, which is negative 1 in the 1, 1 position, negative 3 in the 1, 2 position, negative 2 in the 2, 1 position, and negative 5 in the 2, 2 position, and that would be my answer. They have to have the same number, they have to have the same size, same number of entries, same number of rows, same number of columns for us to add or subtract our matrices. If they don't, we can't actually do that. So say I had matrix C, which is 1, 5, 6, 7, 9, and 10, I would not be able to add or subtract this to A or B simply because of the fact that this has more rows than these two. It has the same number of columns, but it has more rows, so I wouldn't be able to add and subtract C to A or B. With matrix multiplication, with scalar multiplication, what we do with our matrix A, we multiply by this number C, is that C is going to distribute onto each one of the entries, not just a single entry, but every entry. So again, I have my B matrix, which was 2, 5, 7, 9. Say I want to multiply this by a -2. So multiply this by a -2. And so every entry is going to get multiplied by a -2. So it'll be -4, -10, -14, -14, and -18. And no comma there, so let me take that comma out. And that's just how it works. Now I can add two matrices first and then multiply by the scalar, or I can distribute the scalar onto each one of those matrices and then add the two. Similarly, I can add two scalars and then multiply it by the matrix, or I can multiply the first scalar by the matrix, the second scalar by the matrix, and then add those two answers. So let's do some addition and subtraction. I'm going to do my A plus B, so I'm going to take this plus this. That's going to give me 3. And 3 plus 14 is 17. 0 plus 22 is 22. And 7 plus 6 is 13. So now I'm going to do 3C times or minus D. So first I'm going to do my 3C, so 1, 5, 8, 92, 12, and 6. And then I'm going to subtract off my D, which is 10, 14, 7, 2, 5, and 61. So I'm going to do it step by step here. I'm going to do 3 and 15 and 24 and 276 and 36 and 18. That's my 3 times my C. Then I'm going to subtract off 10, 14, 7, 2, 5, and 61. So going position by position, 3 minus 10 is going to give me -7. 15 minus 14 is going to give me 1. 24 minus 7 is going to give me 17. 276 minus 2 is 274. 36 minus 5 is 31. And 18 minus 61 is, let me see. 18 minus 61 is -43. 43. And then this is my final answer. So this was B. And then if I want to do 2A times 3E, so 2 times A, so 2 multiplied by A, 1307, minus 3 times E, which is 6, 12, 14, and 5. I'll let you all do that. And hopefully what you got is -16 minus 30, -42, and -1. I'm going to do F multiplied by 2C and add them together. And then A plus 5F. And this is, I'm going to let you do both of those, but this one, well, I'll let you do D first, and then let's talk about E. So pause it now and see if you can do D. And when you did D, hopefully what you got, if I didn't make any mistakes, is 2, 19, 94, 201, 39 and 16. That's that one. Now E, I said I wanted you to do D before you did E. The E is one you can't do. Why? Because A is a 2 by 2, 2 rows, 2 columns. F is 3 rows, 2 columns. These don't match, so you can't actually do those. So you can't actually add those because they don't match. The sizes don't match. Now when you do matrix multiplication, you have to pay attention that when you do matrix multiplication, it is not commutative. And this is what I mean by that. When we say it's commutative, we say A multiplied by B. So not in matrix form. So just in general, the matrix or just multiplication of real numbers is commutative. Gosh darn it, hang on a second. Keep using, I don't know what the heck that thing is. Okay, so A multiplied by B is B multiplied by A. That is not true of matrices. So A matrix multiplied by B matrix may or may not equal the B multiplied by the A matrix. So since it isn't always true, then we say that it's not commutative. But it is associative, which means I can do A times B and then multiply the answer by C. Or I can multiply B times C and multiply the answer by A. It's also distributive, so you can distribute that C onto each one of them. And you can distribute the C also on each one of them going in this direction. But it is not commutative. Can be sometimes, but not always. And the last thing I just want to show you is the identity matrix. So an identity matrix is described with an I and then just a single subscript, because an identity matrix is special. It's a square matrix, and square just means it has the same number of rows as it does columns. So the number of rows equals numbers of number of rows equal the number of columns. And then we always say the identity matrix is defined as I, and then the subscript tells you the size, and it's square. The other thing that's special about the identity matrix, this is called a diagonal. This is going down in this position. It's going down in this position. These are the A11, the A22, the A33, the A44, all the way down to ANN. That's a diagonal. And with the identity matrix, we have ones in that diagonal, and then we have zeros everywhere else. So along the diagonal, we have the ones, and then everywhere else we have zeros. So above, and we say above and below the diagonal, we have zeros. Now, with matrix multiplication, what we do is we multiply the column entries in one matrix by the row entries in the other matrix. Like, what does that mean? Well, let me do the A multiplied by B. So what I do to make sure that I always have it set up right is I offset my A matrix. I put it down to the lower left, and I do -1, 5, 3, and 2. Now I take my B matrix and I offset it up to the right, almost like a power. And I do 3, 6, 4, -8, 0, and 12. And you're going to say to me, those aren't the same size. That's okay. And the reason is because I'm going to take these two entries, multiply them by these two entries, and I'm going to add those entries together and put it right in that position. So I'm going to call this, C11. This will be the answer for this multiplication. So C11 is going to be equal to -1 multiplied by 3 plus the 5 multiplied by that -8. To get my next set, I'm going to multiply these two numbers by these two numbers. I'm going to call this the C12. So C12 is going to be equal to the -1 multiplied by the 6 plus the 5 multiplied by the 0. I'm going to do my next entry, and I'm going to multiply these two times these two. I'm going to call this a C13. So C13 is going to be the -1 multiplied by the 5, or excuse me, by the 4. Change that to a 4. And then I'm going to add to it the 5 multiplied by that 12. So far, what I have is -43, and this is -1, and that's 60 minus 4. Yeah, 60 minus 4 is 56. Okay, so now I'm going to multiply the 3 and the 2 by the 3 and -8. I'm going to call this a C21. So the C21 is going to be equal to the 3 multiplied by the 3 plus the 2 multiplied by the -8. So 9 minus 16 is -7. Now I'm going to do the 3 and 2 and multiply it by the 6 and 0. So C22, C22. So 3 multiplied by the 6 plus the 2 multiplied by the 0, which is going to give me 18. And then my last one, I'm going to go back to using the green, is the 3 and 2 multiplied by the 4 and 12. I'm going to call that the C23. So C23. 3 multiplied by the 4 plus the 2 multiplied by the 12. So I'm going to have 12 plus 24 is 36. Now, this is what the C, or the answer, looks like. My answer, going along the first row, is going to be the -43, the -1, and the 56. Going along the next row, I'm going to get -7, 18, and the 36. So the algorithm is, if I have the A matrix multiplied by the B matrix, then in the first position, it would be my A11 multiplied by my B11 plus my A12 multiplied by my B21. And if I had another one, I would be going, like if I have another entry, I would be doing the A13 multiplied by the B31. I'm basically taking the entries, the row entries of my A matrix, and multiplying by the column entries of my B matrix, and I add those things together. So then my next one, so ... then I'd go to the A11 and multiply it by the next row column over in the B, so B12 plus the A12, the next entry down in column 2 would be the B22, and etc. And then my next row in the A would be the A21. The first column is the B11. The next entry in my second row in A is A22. The next entry in my column, in the first column in B, would be the B21, and I'd add these together, and you can see the pattern. That's how you do matrix multiplication, which is why long ago and far away, before we had calculators that did this for us, I had a professor that showed me this trick. A goes down here, B goes here, and then you just multiply these row entries times these column entries and add those answers together. These row entries, these column entries, add them together. These row entries, these column entries, add them together. And that's how you do it. It's pretty straightforward as long as you remember to offset it slightly. You can just kind of point and say these things work out. Now, the reason the size doesn't matter is because what I'm doing is I'm taking my A matrix, which was a 2, 2. Excuse me. Sorry. Still not quite feeling well. So I have an A, which is a 2 by 2 matrix. And then I have my B, which is 2 rows and 3 columns. Now, the reason it works out is because those two things match up, that your answer, and it will work out, your answer will be the AB matrix. When you multiply it together, the answer will be these two remaining. So it'll be a 2 by 3 matrix when you get done. So let's take a look to see if B or C, if we can do the multiplication of B multiplied by C. So that's the first thing I actually like to do. So my B matrix, which is a 2 by 3, 2 B matrix, this is a 2 by 3. My C matrix is a 3 by 2. These match up. So my answer, the BC matrix, when I get done, will be these two, which is a 2 by 2 matrix. So let's go ahead and do that multiplication. So I'm going to erase all of this. Since we can do this, I'm going to write my B matrix kind of down to the left. So 3, 6, 4, -8, 0, 12. This is my B matrix. And then I'm going to put my C matrix up here. 4, -2, 5, 10, 6, and 9. I'm going to multiply these times these. I'm going to call this C. I'll call this A11. So I'm going to go over here and do A11, which is going to be 3 multiplied by 4 plus 6 multiplied by -2 plus 4 multiplied by 5. I'm going to do this times this. I'm going to call this the A12. So 3 multiplied by 10 plus 6 multiplied by 6 plus 4 multiplied by 9. I'm going to do these, multiply these. I'm going to call this the A21, which is -8 multiplied by 4 plus 0 multiplied by -2 plus 5 multiplied by 12. And then my last one, which is this times this, A22 position, A22, is going to be -8 multiplied by 10 plus 0 multiplied by 6 plus 12 multiplied by 9. So my answer is going to be, okay, so my answer is going to be 20. And then 120, if I didn't make any mistakes. And then 28, and then 28. So that is what B looks like. So let's take a look at C and A. So C is a 3 by 2. A is a 2 by 2. 2 by 2. 2 rows, 2 columns. These two match. That means the answer will be of that size. So C multiplied by A will be a 3 by 2 matrix. And I'll let you all try that. And then I'm going to look at B, which is a 2 by 3. So 2 by 3 matrix. And the D matrix, which is a 3 by 3 matrix. These two match. So a B multiplied by the D will produce a 2 by 3 matrix. And I will let you all try that as well. And that's it for this video. Oh, wait, I'll give you the answers. Your C multiplied by A matrix should be, when you did all the math, 26, 40, 22, 22, and 43, if I didn't make any mistakes. And then your b multiplied by d should be 60, 41, 2, negative 16, 120, and negative 216. And now that's it for this video.